Hello there, children, and welcome to Freaky Factoring. Now, each of you should have picked up a factoring handout in class yesterday or before that, and it should look something like this. So please make sure you have that with you as we go through these examples. These are the steps for factoring anything, and you will need to know these steps through and through by the time we take our next test. Alright, first thing we're going to factor is 2x squared minus 18. And following the rules on your sheet, the very first rule says to look and see if there is a GCF, if there is a greatest common factor. You must always do that first. In this case, yes, both of our terms here are divisible by 2. So what you do is you write it out to the left and then divide each term by your greatest common factor. So 2x squared divided by 2 is just x squared, and negative 18 divided by 2 is negative 9. You do have to write it here. You can't just make it go away. It has to stay there. You're just factoring it out to the side. The next thing you do is you look and see how many terms are there. And this particular one has 2 terms. So we're going to go look at step 3. And step 3 says 2 terms. What are they? There's 3 special things they could be. They could be a difference of squares, a difference of cubes, or a sum of cubes. And if there are none of those 3, then you're done. It's fully factored. This one happens to be a difference of squares because we have x squared, and then the minus is a difference, and 9 is 3 squared. So this is a difference of squares. And when you have a difference of squares, it factors into, if you have a squared minus b squared, you get a plus b and a minus b. It doesn't matter which comes first, plus or minus. So in this case, we're going to keep our 2, and then we're going to have x plus 3 and x minus 3. And that is your difference of squares fully factored. Alright, here's another example. First we look for a GCF. We don't have one. We have 2 terms, so we look and we say, is this a difference of squares? No, these are not perfect squares. Is it a difference of cubes? Yes, these are both perfect cubes. So we have x cubed minus 2 cubed. And there is a formula that you need to know, and that is that if you have a cubed minus b cubed, and this is on your worksheet or your handout here, it factors to a minus b, and then a squared plus ab, and then plus b squared. If you had a sum of cubes, a cubed plus b cubed, then that would factor to a plus b, and a squared minus ab, and then plus b squared. So you need to know these 2 things. There is no sum of squares. There is a difference in sum of cubes, but there's only difference of squares. So in this particular one, we would factor it to x minus 2, and then a squared would be x squared, plus ab, so plus 2x, and then plus b squared. So if b is 2, then 2 squared is 4. And that's your factored difference of cubes. I'm not going to do an example of the sum of cubes, but it's just the same thing. You have to look at the formula and know it. Alright, here's another one to factor. So do we have a GCF? Remember, always ask that question first. In this case, yes, each of these 3 things are divisible by 2. So we're going to factor the GCF out to the side. We have y squared plus 4y plus 4. And then this is what we did before, but we can review that anyway. We say what factors of 4 will also add to get 4. And that would be 2 and 2. 2 times 2 is 4, and 2 plus 2 is 4. So we know that this is 2, and then y plus 2, and then y plus 2. It's supposed to be y, not an x. And then when you have 2 of the same thing, the most simplified answer that you can give, and the proper one, would be 2 times y plus 2, and then all squared. So make sure you know that. It's called a perfect square trinomial. Alright, here's another example. We have 5x squared plus 16x plus 3. So is there a GCF? Is there a common factor for 5, 16, and 3? And no, there's not. So we're going to move on. How many terms are there? There are 3 terms. So now we're going to look at step 4, ax squared plus bx plus c. And this time our a value is not 1. So we have to actually follow this. We call this splitting the middle. So here's what you're going to do. You're going to identify a, b, and c. That's just the coefficients for each term. Then you're going to write AC, a times c. So AC in this case would be 5 times 3 is 15. And then you're going to identify B. And B in this case is 16. So instead of just looking at factors of C that add to get B, we are now looking for factors of AC that add to get B. So we need factors of 15 that add to get 16, and that would be 15 and 1. So now you can't just don't just ignore me and keep going. Now listen. Now you're going to split the middle. You're going to split your middle term, your 16x, into a 15x plus 1x. You use these two numbers that you figured out, and you split it. So 16x is 15x plus 1x. We're not changing it. We're just writing it in a different way. And then go ahead and put your 5x squared plus that, and then plus 3. So we still have the same thing. We've just split the middle. And when you split the middle like that, you now have 4 terms. So if you've got 4 terms, then now look at step 5 on your factoring sheet. And this is what you would do if you were given 4 terms to begin with, or if you've split the middle. You group the first 2 terms together, and you group the second 2 terms together. Then you look at the first 2, and you factor out a greatest common factor, a GCF. So 5x squared and 15x have 5x in common. So I'm going to factor out a 5x, and then I would have x plus 3 left over. Because if I were to distribute this back, I'd get 5x squared plus 15x. Then you look at the second set, and you factor out any GCF you have. In this case, I don't have a GCF, 1x plus 3. So if you don't, write the plus 1, and then write x plus 3. It is very beneficial to you to write this plus 1 right here. Okay, so once you've done that, you notice that you have the same factor written in here twice. If you've chosen the right numbers there, these will always be exactly the same. So that is one of your factors. Write it down. And then the other factor is whatever's left over. So do you see how we have a 5x and we have a plus 1? 5x plus 1 is your other factor. And so now we have fully factored 5x squared plus 16x plus 3. And then, of course, it says in the handout, if you had factored any GCFs out in the very beginning, you would make sure that you carried it all the way down and wrote it here. Of course, we don't have any, so it's no big deal. But if you have them, don't forget them. Now, check if you can factor either set of these parentheses, because sometimes in the more complex ones, we could factor even further. But x plus 3 is fully factored, 5x plus 1 is fully factored. If you're still not sure you did it right, you can always FOIL it back out to make sure, to check it. But this is the final factored version of 5x squared plus 16x plus 3. Okay, here's an ugly one, 4z squared plus 20z plus 25, and we want to factor that. So first we look and see, do we have a GCF? Is there something that goes into 4 and 20 and 25? And there's not. So then we figure out what is AC and what is B. In this case, A is 4 and C is 25. 4 times 25 is 100. B is going to be 20. So we're looking at factors of 100 that add to get 20. And you think and you think and you think and you say, well, 10 times 10 is 100 and 10 plus 10 is 20. So we're going to use 10 and 10. Now remember, you take those two 10s and you split the middle. So we've got 4z squared plus 10z plus 10z plus 25. And then once we've split the middle, we group first 2 together, second 2 together. So now our GCF for just the first 2 is going to be 2z, goes into both of those. And then we've got a 2z and then plus 5. And then in our second group, these are both divisible by 5, and I'm going to write positive 5. And then we've got 2z plus 5. And now we do notice that these are the same, so that is one of your factors, 2z plus 5. And then the other factor is what's left over, 2z plus 5. And in this particular one, because it's a perfect square trinomial, we are going to write it 2z plus 5 all squared as our final answer. Okay, here's an example of if you were asked to solve. So if we are asked to solve for x, and we do have this middle term here, so we know we can't just isolate the x, we're going to have to factor and solve. So here we go. Do we have a GCF? All three of these terms are divisible by 3. So we're going to factor out a 3, and we're going to have 2x squared minus x and minus 21 equals 0. So then we say, okay, well, a is 2 and c is negative 21, so ac is negative 42 and b is negative 1. So what are factors of negative 42 that add up to get negative 1? And you think, and then you say, oh yeah, negative 7 and positive 6. Multiply together to get negative 42, and add together to get negative 1. So we're going to split the middle. Keep the 3, don't forget about him. And then we've got 2x squared minus 7x plus 6x. And no, it doesn't matter. You could write plus 6x minus 7x. It would still give you the same thing in the end, so it's okay either way. And then minus 21. And then we group. So 2x squared minus 7x, the only thing those two have in common is an x. And then we've got 2x minus 7 left. And then plus 6x minus 21, those both have a 3 in common, a positive 3. And if we factor out the positive 3, we have 2x minus 7 left. These match as they are supposed to, so that's one of your factors, 2x minus 7. The other factor is what's left over, x plus 3. Don't forget about this guy. He has to be there. And then we're solving, so we're not done yet. We have to say that equals 0. Alright, so then once we're solving the equations, what do? Do y'all remember? We are going to set each piece equal to 0. So if I said 3 equals 0, that's not going to give you anything. So that doesn't matter. No, x does not equal 3. Then if we set 2x minus 7 equal to 0, we would get 7 halves. Sorry, I'm running out of room here for x. And if we set x plus 3 equal to 0, we'd get negative 3 for x. So our answer, x equals 7 halves and negative 3. Alright, last example. For good measure, I wanted to do one of these too. What if I said find the x-intercepts of g of x equals 3x squared minus 8x plus 5? So, same thing as if we were solving, x-intercepts happen when g of x is 0. So we need to factor. We need to say, alright, is there a GCF? In this case, no. Then we say AC is 15. So what factors of 15 add to give us a b of negative 8? Factors of positive 15 that add to get negative 8. And then you think and think and think, and then you get negative 5 and negative 3. Or negative 3 and negative 5, either way. So we're going to split the middle. So we've got 3x squared minus 3x minus 5x, because that still equals minus 8x, plus 5. And we group. Now out of here we can get 3x, and then we factor out x minus 1. And then out of this group, we can take out a negative 5, and we get x minus 1. So one of our factors is x minus 1. The other one is 3x minus 5. We're setting these both equal to 0. If we set them each equal to 0, we get x equals 1 and x equals 5/3. But since we're finding the x-intercepts, we write them as ordered pairs. The x-intercepts are at 1, 0 and 5/3, 0. And that is the end of our factoring video.